The year is 1920, and the American lumber industry is experiencing unprecedented growth. Deep in the forests of the Pacific Northwest, massive Douglas fir and oak trees that have grown for decades are being harvested to meet the nation's building demands. The process of creating plywood, a revolutionary building material that layers thin sheets of wood in alternating grain directions, begins long before these logs reach the mill. At dawn, a Ford Model TT truck loaded with enormous logs makes its way along a dirt road toward the Cascade Lumber Mill. The vehicle's solid rubber tires and exposed engine represent the latest in transportation technology. The driver, dressed in wool cap and flannel shirt, navigates carefully around deep ruts while black smoke pours from the exhaust pipe. These logs, some weighing over a ton each, are secured with heavy iron chains that clank rhythmically as the truck bounces over the uneven terrain. The journey from forest to mill is treacherous and time-consuming. Drivers must navigate steep mountain roads, ford shallow streams, and carefully maneuver around fallen trees and washouts from recent storms. The Model TT's maximum speed of 25 miles per hour means that even short distances can take hours to traverse. Many drivers carry spare parts and tools, as breakdowns in remote areas could strand valuable cargo for days. The Cascade Lumber Mill sits on several acres of land, its multiple buildings connected by covered walkways. Steam engines power the entire operation, their constant chugging creating a rhythmic heartbeat that can be heard for miles. Tall smokestacks release white steam into the morning air, while the sweet smell of fresh sawdust permeates everything. The mill operates 6 days a week, employing over 200 workers who arrive each morning at precisely 6 o'clock, when the steam whistle signals the start of another workday. As the truck arrives at the unloading dock, 3 mill workers emerge from the main building. They wear the standard uniform of the era, heavy canvas pants held up by leather suspenders, thick flannel shirts, and steel-toed boots caked with sawdust. These men have worked in lumber mills for years, their hands calloused from handling rough timber and operating heavy machinery. Each worker earns approximately $25 per week, good wages for the time, though the work is dangerous and physically demanding. The workers operate a manual chain hoist to carefully remove each log from the truck bed. Every movement is deliberate and coordinated. A single mistake could result in serious injury or death. The mill supervisor, a weathered man in his 50s with a graying mustache and wool vest, watches the process intently. He carries a pocket watch and leather-bound ledger, documenting every log that enters the facility. His experience spans 3 decades in the lumber business, having started as a sawyer's apprentice before working his way up to management. Once unloaded, each log undergoes careful inspection. The supervisor examines them with a small hammer, tapping gently to test for density and internal defects. The sound tells him everything he needs to know about the wood's quality. Solid logs produce a sharp, clear tone, while those with internal rot or damage create a dull thud. Only the finest specimens receive a white chalk mark indicating they're suitable for plywood production. Rejected logs will be sent to the regular lumber operation for cutting into boards and planks. The selected logs are then moved into the mill's main building, using iron hooks attached to long wooden handles. The building's interior is a marvel of industrial engineering for its time. Massive steam engines connected by an intricate system of leather belts and pulleys power every machine in the facility. The air is thick with the smell of hot metal, steam, and fresh wood. Workers move with practiced efficiency, their movements choreographed by years of experience and the constant rhythm of the machinery. The mill's power system is a complex network of interconnected components. The main steam engine, a behemoth weighing several tons, burns wood waste from the mill's operations to generate power. This waste includes sawdust, bark, and wood scraps that would otherwise be discarded. The engine drives a central line shaft that runs the length of the building, with leather belts transferring power to individual machines as needed. Workers can engage or disengage specific machines by manipulating clutches and belt shifters. The first major step in plywood production begins at the primary cutting station. Here, an enormous circular saw blade, nearly 4 feet in diameter, is powered by the main steam engine through a series of leather drive belts. An experienced operator wearing leather safety goggles and a heavy canvas apron guides each log through the spinning blade. The saw cuts the logs into more manageable sections, while golden sawdust fills the air like snow. This operator, known as the head sawyer, commands respect throughout the mill for his skill and experience. These cut sections then move to the debarking station, where a massive mechanical lathe slowly rotates each piece, while a fixed blade removes the bark in long, continuous strips. Workers adjust the blade pressure using large iron wheels, ensuring the bark is removed without damaging the valuable wood underneath. The discarded bark falls into organized piles that will later be burned to help power the mill's steam engines. Nothing goes to waste in this operation. Even the smallest wood scraps find purpose somewhere in the process. Before the actual veneer cutting can begin, the wood must be properly prepared. Workers use thick rubber hoses to spray the logs with hot water, softening the fibers and making them easier to cut into thin sheets. The water comes from the mill's own steam boilers, heated to precisely the right temperature to penetrate the wood without causing damage. This conditioning process can take several hours, depending on the species and size of the wood being processed. The logs are then positioned in a specialized lathe designed specifically for veneer production. This machine represents the cutting edge of 1920s technology, with precision-engineered components that allow for incredibly thin cuts. The lathe bed is made of cast iron and weighs several thousand pounds, providing the stability necessary for accurate cutting. Workers use block and tackle systems to position the heavy logs, a process requiring both strength and coordination. The veneer lathe is perhaps the most impressive machine in the entire mill. As the log rotates slowly, a long, sharp blade peels the wood in a continuous sheet, much like unrolling paper from a giant roll. The operator, who has trained for years to master this delicate process, carefully controls the thickness by adjusting precision screws. The thin wooden sheets emerge damp and flexible, requiring careful handling to prevent tearing. A skilled operator can produce veneer sheets as thin as 1/16 of an inch with remarkable consistency. These freshly cut veneer sheets are then carried to the drying room, where they're carefully arranged on wooden racks. A wood-fired furnace heats the space, creating the controlled environment necessary for proper drying. Workers periodically check the moisture content by gently touching the sheets, their experienced hands able to detect when the wood has reached the optimal dryness level. The drying process must be carefully monitored. Too fast, and the wood will crack. Too slow, and production schedules fall behind. The drying room operates on a schedule as precise as a railroad timetable. Different wood species require different drying times and temperatures, and the mill foreman maintains detailed charts showing exactly when each batch should be moved to the next stage. Temperature and humidity are controlled by adjusting dampers and vents, a skill that takes years to master. The room's design allows for natural air circulation while maintaining consistent conditions throughout. While the veneer dries, other workers prepare the adhesive that will bind the layers together. In 1920, most plywood manufacturers used casein-based glue made from milk proteins. The glue is mixed in large iron cauldrons and stirred constantly with wooden paddles to ensure proper consistency. The mixture must be kept at exactly the right temperature and thickness for optimal bonding. Too hot and the proteins denature, too cold and the glue won't spread properly. The glue preparation is both art and science. Workers add precise amounts of lime and other chemicals to activate the casein, creating a chemical reaction that produces the adhesive properties. The mixture bubbles and steams as it cooks, requiring constant attention to prevent burning or overcooking. Each batch is tested by applying it to sample pieces of wood and checking the bond strength after curing. Once the veneer sheets are properly dried, the assembly process begins. Workers use wide brushes made from natural bristles to apply a thin, even coat of glue to each sheet. The application must be perfect. Too little glue results in weak bonds, while too much creates messy squeeze-out and wastes expensive adhesive. The brushes are cleaned frequently in hot water to prevent glue buildup that could create streaks or uneven application. The glued sheets are then carefully stacked with alternating grain directions. This cross-grain construction is what gives plywood its exceptional strength and resistance to warping. Each layer is positioned using wooden rulers to ensure perfect alignment, and workers apply gentle pressure to help the initial bonding process. The stacking must be completed quickly before the glue begins to set, requiring smooth coordination between multiple workers. Quality control inspectors examine each assembled panel before it goes to the press. They check for proper glue coverage, correct grain orientation, and any defects in the veneer that might compromise the finished product. Rejected panels are disassembled and the veneer reused where possible, though some pieces must be discarded entirely. The final step takes place at the hydraulic press, a massive machine made of cast iron with large hand wheels for applying pressure. Workers position the assembled veneer stack between metal plates and slowly turn the wheels to apply thousands of pounds of pressure. Gauges show the exact force being applied, while excess glue slowly oozes from the edges. The press operator monitors both pressure and time, following specifications that have been refined through years of experience and experimentation. The pressing process takes several hours, during which the glue cures and creates permanent bonds between the wood layers. Workers clean away the excess adhesive with cotton rags, ensuring clean edges on the finished product. The press room operates multiple machines simultaneously, with panels entering and leaving on a carefully orchestrated schedule that maximizes efficiency while maintaining quality standards. When the pressing is complete, what emerges is a single sheet of plywood, stronger and more stable than any single piece of solid wood of equivalent thickness. The finished panels are inspected one final time, graded according to quality standards, and prepared for shipment. Some panels go directly to local customers, while others are loaded onto railroad cars for distribution across the country. This revolutionary material will go on to transform construction, furniture making, and countless other industries. But in 1920, it represents the perfect marriage of traditional craftsmanship and industrial innovation. Skilled workers using steam-powered machinery to create something entirely new from the ancient forests of America. The plywood industry is still in its infancy, but mills like Cascade are laying the foundation for what will become a multi-billion-dollar industry. The entire process, from log to finished plywood, takes place within the walls of mills like Cascade Lumber, where the rhythmic sounds of steam engines, spinning saw blades, and working men create the industrial symphony of early 20th century manufacturing. Each day brings new challenges and innovations as this young industry continues to evolve and perfect its methods.